So today we will learn about cache with the question on the board. So in the question it says the cache is with the 128 bytes and it has the write back policy and then allocate on write. And it also have a 1 megabyte of the byte addressable memory. And then the question asks us to calculate the full associated with block size of 16 bytes. How many bits of overhead in total? So we were first calculating the address memory, and in the question it has a 1 megabyte of the byte addressable memory, so it will have a 2 to the 20 bytes. So it will basically have 20 bits total. So the address memory will be the 20 bits. And the block offset is equivalent to the log of the block size. And then in the question, the block size is given as a 16 bytes. So the block offset will be the log of 16, which is 4 bits. And in the question, it says the write back policy. So the valid bit and then dirty bit will be 1. But regardless of that, the valid bits always have to be 1, and the dirty bit, because it is a write back policy, it has to be 1 bytes. If it is not a write back, it is write through policy, the dirty bit has to be 0. And the tag bit is basically the address memory minus the block offset. So it is the 20 minus 4, which is 16 in this example. The LRU bit is basically the log of the number of blocks, and it is equal to the log of the cache size divided by the block size. So in this example, the cache size is 128 and the block size is 16. So 128 divided by 16, which is 8, 2 to the 3, so log of 2 to the 3 will become 3. So the ARU bit in this example will be 3 bits. And lastly, the overhead. The overhead is basically the sum of tag bit, valid bit, dirty bit, and then ALU bit. So basically the 16 from tag, 1 bit from valid, 1 bit from dirty bit, and then 3 bit from the ALU. So it's basically 21 bits for each of the overhead. But the question asks how many bits of the overhead in total. So we need to basically multiply this number by the number of blocks in this example, and then the number of blocks we calculated here is 8. So the overhead in total as a bits is 168 bits. So the final answer for this question is 168 bits in total. Actually, that is it for this question, and then thank you for watching this video.